endurance also. I've been using Perl since maybe 1996, I think. We were still transitioning from Perl 4 to 5, and at least where I was working at the time. Today, I want to talk about JSON Schema and OpenAPI. Has anyone used OpenAPI in any language? Or how about JSON Schema? Okay, this is great then. This will be perfect. It's kind of an introduction. I wanted to talk for a moment about JSON. Most of you probably use JSON somewhat regularly. For those who don't, JSON is a JavaScript object notation. It's a way to describe JavaScript objects, and they're very simple. They're just made of keys, which are in the blue there, and values. So it's kind of a mapping of, if I were to say, hey, what's the ID? It knows 1. So values can be of various kinds of types. So you can have integers. You can also have booleans, true or false. Most of these are strings, as you can see with the quotations around them. Values can also be another object. So these can be, you can nest JSON objects, which makes for a very rich description of whatever it is you're trying to send over the wire. There's also a null value, which I don't have represented here. Are there any questions about JSON itself, how JSON works? There's also arrays.
I have a stupid question.
No stupid?
Call JSON most of the time, some people call it JSON.
Yeah.
No. Is there another way to say it?
I've heard.
Do you want to always get our attention?
So we've got 3 Jasons here who prefer not to call it JSON because it's a namespace conflict in the human world. So
is it GIF or JIF?
I'm not going to go there. So we pronounce it letter J hyphen SON. So, but if JSON at your work is appropriate, that's, I think people.
I believe the actual pronunciation is Jason.
Yeah.
I've always used it wrong.
Yeah. So, any other questions? That was an interesting question, actually. It is designed to be simple and easy for humans to read and work with. It was kind of in many ways, JSON is a reaction to XML, which is a very heavy and well-defined specification for describing parts of a document. But its simplicity also usually means that the burden of rigorous type checking and other kinds of functions you would expect to do on a document are left, they haven't been done yet. They're left to the user, the validator, the developer, whoever's working with the JSON document. So if in Perl, if we get some JSON, we have to look at it very carefully. We have to be rather defensive about it. In Perl and JavaScript, loose typing is normal and something we enjoy, but there are times where you really want that extra level of validation, especially when you may be either generating JSON for a client downstream from you that is strongly typed. So let's look now for a moment at, let me see which direction this, okay, it's not that way, it's that way. Is that, can everyone see that?
Yeah.
Okay. I wish I had a alternate screen here too. So here I have a we'll just do that. Did you do something? What did he do? I wasn't paying attention.
Just turn the camera on.
Oh, thank you. So I've got 3 files in this directory. There's bad JSON and good JSON, and then our file that we're using to validate. Because we're pretending that there is no way to validate JSON except how we typically do it. Let's look at that a little bit more closely. So here's our script that we're going to use to validate the JSON. In the first line, we pull in the file, we slurp it from the file system. Then we convert it using decode JSON into a Perl. It's not an object, it's a reference, hash reference. It may be a rich hash reference containing arrays and things like that, nested things. Then we're going to do we're going to start our validation here. We're going to set up a little array called errors, and then for each one of these, we're going to say we're going to generate a little error message. So we're going to push into our errors array the string ID is missing, unless unless the ID exists in the object, and we'll do that for each field that we're interested in: URL, body, user. And once we get into user. We'll load this here. User is it's kind of a rich, it's a nested object, or a nested hash in Perl terms, but an object in JSON terms. So in order to deal with that, we have to first check for the existence that key exists there. Then we can start digging inside of that user hash and looking for the fields inside that. And then finally, now, up to this point, we're only checking to see if the key that we're looking for is there. We haven't talked about types. We haven't talked about ranges of integers. We haven't talked about enumerations. Here's a poor man's enumeration right here. The value is invalid unless the type is either user, admin, or I came up with passerby. That's one of the things I came up with. So otherwise, we'll push an error in there. If there are any errors, we will die and spit those errors out back to the user and give them a chance to fix their JSON document. Otherwise, we would proceed with whatever it is our program is doing here. And you can see there's a lot of work going on here. We can run this.
Scott?
Yes?
You glossed over something, but I think it's important. The JSON objects map very cleanly to Perl data
Hashes,
structures.
yes.
The exception of Booleans, maybe, the mapping is almost exactly one-to-one and trivially bidirectional.
Yes.
Versus other markup languages like XML, where that is definitely not true. You have an obvious...
Strong types. XML is about strong typing, and JSON is not. Yeah, that's a good point. Did everyone catch what he was saying? The JSON objects in JavaScript map almost one-to-one into Perl references of the same kinds of things.
Even this would be, in some cases, inadequate because more recent JSON specs will allow what you have, my object, could actually end up being just an array ref or just even a value in the most recent JSON.
For sure.
Yeah.
In this case, I'm expecting an object,
Yeah, expecting
a JSON object, because that's what's in my head, right? I've got the spec in my head, and I'm trying to translate into code, but that's a very good point. It can be an array, or it can be just a plain string. Those are both valid JSON documents, as far as JavaScript is concerned.
You also might want to know exists versus defined, doing very different things to your hash.
Right.
Which is why you're using exists.
Yeah, exists checks for the presence of the key before it acts on it.
Define with make.
Like a 0, if any of the values in there were 0, if it was ID 0, exists would return true, but if I just checked for the key itself, it might return false. So, good points. Okay, so let me run this test. We'll do it on good, and that's what we would expect. And bad. Now we have body is missing and URL is missing. If I diff these two, good and bad, you can see that the good has a body and URL, whereas the bad doesn't. And so our validator worked. That's great. Now, so we're checking to see that the document has the parts that we're looking for, and that we're doing some pretty poor man kinds of duck typing there. You saw my little enum with the regular expression, but how would anybody using our service, let's say this is part of an API or something we wrote, how would they know what we're looking for?
RTFC.
We'd have to write a manual, wouldn't we? Or some documentation or something like that. Or they would just keep trying until they got it right? They'd see the error messages coming back and they would just keep trying. But we've now split our implementation from our customers, really. So we could make this a little bit better. I'll show you my second attempt. Now, this one is a little bit more magical. I'm leveraging the JSON Pointer module from Modulicious, which is kind of nice. It gives me a a syntax that allows me to check for the presence, of fields with simply looking at if pointer contains this. Under the hood, it's doing the same kinds of things I was doing by dereferencing the hashes, but doing it in a safe way. It won't auto-vivify my object, things like that. It's very nice, and we have now a very compact. I can simply add more things to that fields array up the top if I want to check for more fields. That's nice, but I still don't have type checking. I still don't have any boundaries or anything else that would be useful in my schema validator. So, and this is where JSON schema comes in. Are there any questions? Please raise your hand if I'm going too fast, or any observations you want to make. JSON schema is a fairly fast-moving specification for describing and validating JSON documents. I wrote my first naive JSON schema validator against the draft, the 03 draft in 2014. Draft 04 is the most widely deployed specification right now. 4 and 5 are the same. 5 was just some clarifications on 4. 6 is the current standard. There aren't many 6 validators out there. 7 is almost finished, and 8's the scope of draft 8 is fairly well defined at this point. So almost every year they're looping on and iterating on. They're just finding little edge cases in the spec that they're fixing and nailing down and arguing about. It's kind of fun to watch. Changes from one draft to the next, and there's kind of a standards body that's doing this, are incremental and mostly backward compatible, but occasionally there's an incompatible change you'll have to watch out for. So when we talk about validators, in the world of JSON schema, you have your document, which is sometimes called an instance, and then there's the description of the document, which is called the schema. A schema describes the shape of your JSON document, as well as the expected types. When I say shape, I mean what keys should be in there, nested objects, arrays, and what the types of the values on those keys would be. If you're doing one-off validation, you give your schema to a validator where it gets parsed. Then you pass in your document, and the validator compares your document against the schema, and if there are any inconsistencies found, like the one we wrote, it will give you a friendly list of errors back to the user. Otherwise, control just passes back to your program. Any questions? So it works a lot like what we wrote before, except in a very, very clean way and well-defined. So this is a schema. This is the simplest possible schema. It validates all documents, and it has no requirements or properties. When we add constraints, we do that by describing what kind of thing we're looking for. So in this case, we're saying what you pass me should be an object, a JSON object, which means starts with curly braces and has some keys and some values in it. Then we say, and the properties of this JSON object, there should be 5 of them. Street 1, street 2, etc. Each of these properties is optional because none of them is marked as required. If the property is present in the source document, however, then that property must conform to the constraints in the schema. So in this case, it would be strings. One interesting thing about JSON schema is that it itself can be described in JSON. So it's fun to read the specification for JSON written in JSON schema. So if you're writing a validator, you could take the schema itself and run it through, and that'd be an excellent test to see if your validator is working. Here's an example document we want to validate in the blue. We can validate this document against the schema. Validation compares the fields in the document against the fields in the schema, checks their value types, and applies any other tests we may have required. So if we were thinking about it how we wrote the other program, we would say, we'd look at the schema and we'd say, okay, I'm looking for an object. And then we look at the data comes in, it's an object. Okay, good, next. It looks like there's going to be 5 fields we're looking for. They're not ordered, because JSON objects like Perl hashes are not ordered. So we'll just start at the top anyway. Street 1, is there a street 1? Yes, there is. Is it a string? Yes, it is. Good, next. Street 2, is there a street 2? No. Is that okay? yep, that's okay because it's not required, and so forth. So, yes?
Can you specify, say this object must have these properties, and then any other properties are allowed, but if these properties are like a
Yeah.
wild card?
Yeah, you can do strict checking where you say it cannot have any more fields than this. So what you're describing, this would work for that. So if you had 20 other fields, they would not be validated because if they're not present in the schema, it's by default allowed.
But they would not be invalidated as well. Is also
Correct, there'd be no way to check them. But you can turn on strict and it would say, whoa, whoa, you've got more stuff than I was expecting here.
Perl has loose typing. How does it do an int versus a string if you're running the validator?
That's a very good question. We can dig into that a little bit later if you remind me. It uses the same kind of heuristics that the JSON parsers use. So if you look at JSON XS, it uses some of the XS, looks like a num, those kinds of heuristics. So it goes through a few of them to give its best guess. So let's look at some actual code that uses a validator here. CPAN has a handful of JSON schema validators. JSON : schema is the probably the first one you might find, but it's a little bit old. It actually only implements a portion of the 03 spec, which is still fairly current. I mean, if you wrote 03, it would work in most of the validators today. We're going to use tonight JSON : validator by Jan Henning Thorsen, aka Batman, which validates JSON schema version 4 and 5, which are the same. So this little program, this program will read in our schema. Here's where we read in the schema. We create a new validator object, and then we point it to the schema. So and this is just going to use my local file system. One interesting thing about JSON validator is that you can also pass it a data : and it will read from the data section of a Perl document, __ all caps data. If you pass it an HTTP or HTTPS URL scheme, it will go fetch it for you. So this, what's that? I don't know about that. That's a great question. You can try that and let us know. So this is an interesting paradigm now, is that I think one of the ideas was along the same lines as they did with XML in the day, where at the top of your document you can specify where to go to get the validation for these things. And you can create, you could have an authoritative US address validation scheme or a phone number or email or components or large things as well. It makes for a very rich experience. Once we've pulled in the validator and given it the schema to parse, here we're going to slurp a file into $data. Then we're going to assume that's JSON, decode it, and put that in $document. This is the validation step right there. This applies the schema to your document and returns any errors. And then you can just check if there are any errors. It would say so. Otherwise, looks good to me. You move on with whatever your program's doing. So these lines here do pretty much what mine did, except that this will also do type checking, bounds checking, apply regular expressions. There's a very rich set of things. And we'll get, my next slide has a list of these things, but I wanted to show you as a demo. We'll go into, so here I have address, here's my schema. I'm using JSON here. You can also use YAML. In fact, later we will use YAML. So JSON schema can be described in JSON or YAML. Either one of those is acceptable. We're looking for an object whose properties are what we described before. Here's our JSON document. It's the same as what we had before. And here's our file. This is what I showed on the screen a few moments ago. So we'll say Perl test. Now what's going on there? Zip expected string got number. You see that? Yeah. So which is correct. If you look at the JSON document above, it is actually a number. So if we go up into 04, I fixed that here. There's no difference in the programs, just in this here. So we'll run that again. Looks good to me. So everything's good there. So we'll catch all kinds of interesting types. You actually get type checking, which is when you need it. It's really nice. So here are some of the other nice things that JSON Schema can give you. Are there any questions at this point? So we have enums. So we can give a list of valid, acceptable values for a particular field. Anything that's not in that list, sorry. You can apply one of, all of, any of, not to array items. References, so I can point to other schemas from inside my document or other sections of my document. So I can take a chunk out here that because I've duplicated it 3 times, stick it down here, and just refer to it by a reference. I'll show you that syntax in a few moments. You can have regular expressions. It's not quite full Perl regular expressions. They do not want, in fact, the specification explicitly disallows evaling of anything, which makes sense because you're pulling in unknown code and you don't want to be running that. But it can do alternations, it won't do captures, it can do anchoring, it can do character classes. It does most things that you would expect it to, 80-20 rule kind of stuff. String length, array count, property count, integer, max, min. You can set default values for something. If a property is missing, you can then say, well, just set it to this. It has some really nice formatting. So this is both useful for input validation and output validation. There is date time, which is the RFC 3339 or ISO 8601, however you like to refer to it, which is year with a T and then a time and then a Z at the end. Email, it will do email formatting, host name, IP4, IP6, a variety of URIs. In many ways, JSON Schema is what we were using 15 years ago in the XML world. But currently it's much nicer. Will it eventually evolve to be XML again? I don't know. It does not have the strong typing built into XML where everything is some kind of an object that you have to go fetch. But right now it's still very much a pleasure to work with. So let's talk about OpenAPI for a moment. It started out as what was called Swagger. Swagger now is a toolkit for developing OpenAPI-based applications. So Swagger still exists. We'll look at some of the Swagger things out there right now, tools. There's an editor. There are code generators to generate clients and servers. There's a lovely UI that we'll look at. So OpenAPI is the specification for describing your API, and Swagger are some of the tools you might use to accomplish that. Like JSON Schema, OpenAPI specification can be written in YAML or JSON. I like to start with the Swagger editor. I'll show you that right now. I remember which way the screen goes. So it's a little bit small, but over here is all my YAML. And over here, when I make changes over here, it shows up over here. So this is the Swagger editor. If I open up, I'm not connected to the internet. If I open up a new Swagger editor, it will, it has a default pet store in there, which is a very rich description you can always look at as a reference. Like, how do I do enums again? Oh yeah.
Do you want to connect to the internet?
It will be okay without, I think. Yeah. Let's see. And I got to go to this direction. Is it going to stick? There we go. So an OpenAPI specification is what you write as a developer to describe your API. There's some meta information, such as title and author, and then you have the meat of your API, the routes, what the routes accept as inputs and what the routes have as outputs. Those are called parameters and responses. So this is an example of an OpenAPI specification. This would be like the header section. These are the fields that are part of most OpenAPI specs. This is my weather API that I haven't written yet. It gives some general information about the API that might be useful, like might be useful in generating some documentation, some things that humans might want to see. So remember when we were talking about JSON, if you haven't seen YAML before, It's kind of like JSON without the quotation marks and nesting. It uses indentation to denote what something belongs to. So in this case, it's also an object in the sense of a JSON object. On the left are the keys, and on the right are the values. So Swagger is a key whose value is 2.0, a string 2.0. Info has a value that is another object. Description. So I could have described this using JSON. We're using YAML. Any questions about that? I don't mean to throw anyone off. Yes?
You mentioned different versions of JSON schema. Which version of JSON schema is Swagger based on?
The current OpenAPI specification, I think, uses 4. But I don't know. I could be wrong about that. It's either 4 or 6, and I off the top of my head, I don't remember. There will be times when you're writing your OpenAPI specification that you've got to go look at the Swagger documentation. I'll show you, or the JSON schema documentation. We'll get into how these two things relate, OpenAPI and JSON schema. Yeah, so like JSON, the document is usually assumed to be some kind of a hash-like object with keys and values. So down at the bottom you see paths. I'm going to change screens and paths will move to the top here, because paths is the section where all the meat is here. So this describes one route. It starts with the URL, which is time / and then there's a placeholder there, TZ. And then we use get. So you can also have post, put, delete, patch. Any HTTP verb would have its own section under there. We only implement get in this particular call, so it's going to be get time zone. We have a description. That's a human description that will go into documentation. If we were to generate documentation, that would show up there. We'll come back to the xmojo name. Now we have the input section here. Sorry, I actually have highlights here. Well, I don't need to twist my neck. So here's the section of parameters. You can see that the TZ there matches up with the TZ in the URL. That's deliberate. This is how those two get linked. It is in the path. It could also be in the query or in the body. We mark it as required since it's in the path. That's a common mistake a lot of people make, is when they're doing path variables, they'll forget to mark it as required. And things don't work like you expect, and you're wondering why. It's because you forgot to make it required. It's a string, and it has 4 possible values. We've got an enum here. So we're going to accept Pacific, Mountain, Central, and Eastern times. There's a response section here. And we put inside of this response section another description, of course, and then the word schema. This is the keyword for OpenAPI to say, now hand this thing off to JSON schema. So this is how the two are related. JSON schema describes portions of either inputs or outputs. And like if we were passing in a JSON document as the input, we could use the schema validation there also. And YAML is fairly forgiving when it comes to quoting strings. So sometimes you'll see me quoting strings and sometimes not, based on how I was feeling at the time I wrote it. In the responses section, there's one response section for every possible response. So we have a 200 response, which means okie dokie. And we describe what that okie dokie looks like. It's a document that has 2 properties, a date time and an epoch, which is an integer. There's also the possibility of a 400 response, which they gave us something that didn't fit up in one of the 4 time zones that we were expecting. And that's all I have to say there. I could describe it further with what kind of error and what that shape is, but again, in the absence of information, it validates. And so in this case, I'm not strongly caring about what the shape of the error looks like.
So if you had multiple types of errors that it could return, how would you link up the validation of your enum up there with this particular 400?
Well, I'll show you.
And those descriptions, those are for the benefit of anyone reading the schema here, not an indication of something that is contained in that response.
Correct. Yeah, it's purely for documentation purposes. You could say a lot more about it. And there's other ways that, I'm only really showing a very small subset of the OpenAPI spec, but it's very rich and allows you to be quite verbose and descriptive in your responses. Here is a second route that we're doing. We have, this is temperature, latitude, longitude, and then a get. So, and there's also a post. So this one has a second one. You can see again these parameters match up with the parameters in the path. Each data type has some additional restrictions you can apply. Here, because it's an integer type, we have the maximum and minimum available to us. Or I can set a minimum or a maximum value on that. And JSON Schema will test that for us and throw the appropriate error. This is what it looks like in a real API. Let's see. Sorry if that's too small. It's about as big as I could make it, getting everything on the screen. First, we are going to use the Modulicious plugin OpenAPI. We're going to then define our 3 routes. We've got the get time zone, we've got the get temperature, latitude, longitude, and a post temperature, latitude, longitude if I'm a weather station and I want to update my, my weather or something like that. Nothing actually happens on that post. And as you can see, the return values for the get temperature are also hard-coded. We then load the plugin. The plugin, in this specific case, this is not true generally of Modulicious plugins, but in this case it's true. It has to come after you've defined your routes because it actually looks at the routes and does some mapping there. Let's look at that top controller for a moment. This is where we validate the input. And if it's not valid, that first line, we simply return from the controller, and OpenAPI has already handled the problems for us. So by the time we get into the second line of our controller, all the validation is done for us. We don't have to put any validation inside of our controllers. It really is a nice way to separate the concerns. If the input's okay, then we set our time zone variable. Now this is interesting because we're setting an environment variable based on user input. That would seem dangerous in some ways. But because it's been tested already, we know that it's safe to handle. It's going to be one of the 4 enumerated types. We load a new timepiece object, and then we render the response back to the client. We validate input as the first line of each controller. This is the pretty canonical way to do this. And then the last line also gets validated on the way out. You don't have to do this. You can just use the JSON renderer, but the OpenAPI renderer will take your response and hand it off to, again, the specification to be checked, to make sure that you're keeping your promises to the clients, to your clients.
So just for those who haven't used Modulicious before, this essentially has created a web service application, all in one, a web server and the application that it runs that responds to requests with the endpoints that you've set up in your
Correct. Yeah, I sometimes forget. This is an entire web application. This is like Apache plus Mod Perl plus your application running here. Yeah. So notice that there is no validation checking inside of our controllers. It was already done before at that first line of the controller. And we know that the value that we get is one of the enums that we defined. So one of the key advantages of using OpenAPI is that the concerns of input validation, output validation, and documentation are separate from your business logic. Once you're in the body of the controller, the input has already been validated and if necessary, the user notified, or otherwise it's not hitting your controller. So how does the OpenAPI plugin take a schema and know what to do? OpenAPI specifications allow us to use these X extensions here. In this case, the Modulicious OpenAPI plugin author declared xmojo name to be the linkage between the specification and your application. So this tells the plugin to look for a Modulicious route named time of day. We can also use the more Swagger-like operation ID. That would also work here instead of xmojo name. That would make your spec work with any other kind of system like Java, Node.js or Java or Python or whatever it is, that spec could now work in any other environment, other frameworks. So looking at this again, here is where we declare the name of the route. This is a modulicious-ism. So let me show where are we? Okay. Okay, I'm gonna open up the schema. We'll look at weather. So there's our weather application. Here's our JSON schema. There's the header parts up here. Here's our time zone handler. There's our latitude and longitude get. Here's our post, update the weather. Now you can see here in this section, in this parameter section, it requires both latitude and longitude in the path. And that's true also of here. We have latitude and longitude in the path. There's some duplication there that makes for kind of some brittleness. If I needed to update one, I would really want it updated in both, but because I've got it in two places, that's kind of a problem. So what we're going to do is we're going to pull all that out. Let's run this first so you can get a feel for how this works. Weather daemon. So here's our modulicious application. Oh, that's way too small. Okay, I can say curl. Oh, you know what? I forgot that I have I've got a test file. So I've got a test file that's going to exercise our API for us here. I don't want to get too much into test mojo. I'm happy to do that in another presentation maybe. But basically, this will make curl calls for us. Here it's going to make a get call to our time zone tester, and it's going to look to make sure it's got epoch and date time. Then it's going to hit it with a different time zone, and then it's going to compare the two to make sure that they're 2 hours apart. We're going to try a bad one and make sure we get an error, because we want to do error checking as well. We're going to check the temperature at latitude 40, longitude minus 111. And make sure we've got a Fahrenheit, Celsius, and Kelvin. We're going to check some bounds. So 91 is not a valid latitude. That's past the North Pole somewhere. And also we'll check longitude, bounds checking. And then we'll do a simple post because we know that's a garbage. It's not a real route anyway at this point. So we'll do a prove test uphill. Okay, good. So we just ran 28 tests. We exercised our API to make sure that it's going to return everything we want it to. We can maybe I will run that just so you can see how the output looks. We'll start that daemon running, and we'll go curl localhost 3000 API time. Dunno. So this is what happens when you hit something that an enum that you oughtn't. This is the default error response. The value you gave me is not in the enum list, and it gave me what my possible values are, and it says path time zone. So I know that up in my path, I did that wrong.
Can you suppress the regurgitation of what the legal values might be?
I think so. So when you I'm not sure about the current OpenAPI plugin. In the previous incarnation, when it was Swagger, you could do, the sky's the limit. It's all programmatic. So I'm pretty sure you can, but I don't know in this current incarnation.
Just so that you might not want to leak information, in other words.
Yeah. that would be the rare case. I think typically you want the user to get it right.
Right.
But that's a good point. Time, and so let's do.
Can you run that with a capital I, dash capital I? Can you run that with a dash capital I?
Like this?
On the curl.
On the curl,
As a
so
parameter.
passive,
Oh,
minus capital I.
does that include?
It's gonna, just capital I, it will print the headers.
Oh, that's include.
Response headers.
Yeah, dash dash includes the same thing. I use the long ones. So there we go. Oh, 404 not found. Yeah, I haven't hit, there's no URL there.
Cool.
Bad request. And then we'll hit a real one. Pacific Standard Time 8 PDT. That looks good.
Yeah, I just wanted to see the 200 okay and then the 400 request.
Yeah, let me include, that's a little bit richer because it gets the body as well. So there you can see our date time comes back as the ISO 8601 and then an epoch time. That's good. Let's look at the weather or the temperature. Temperature at, we'll say 4040. And Celsius, Fahrenheit, and Kelvin. So we've got all the temperatures there. And if we set a value that is past the valid longitude line, 400 is greater than the maximum of 180 in the longitude thing. So you get a very rich description of the error. I believe it's fairly configurable. I haven't played with that lately, not in this version. Any questions about this so far?
Are those errors coming from the Mojo OpenAPI plugin? Those
Yes.
aren't specified by OpenAPI, are they?
Correct. Okay, so I pointed out that in our specification file there was some duplicated chunks in the weather part, right? Both of them have the same latitude longitude path. Both of them have the same section of parameters. That looks like this here. We're going to do the time zone one first, sorry. Yeah, so we start with this. You can see this parameter here on the right, left, and what we've done is we can abbreviate that on the right. This is references now. This is JSON schema references. You say $ref, and then you give it a path, and I'll show you where those paths live. But the hash means this document, and we're going to look at the parameters key, and under that there should be a time zone key. Also, we can do the same for responses. We can take this schema object here and refer to it in definitions. Typically, the JSON's OpenAPI likes you to use parameters for inputs and definitions for outputs. So we're going to take these two pieces. I'm going to put them back in their context. You're not going to be able to read this. I get it. But just to show you that here are the two things that we're looking at, the input parameters and output. They're going to wind up down here in the definition section and the parameter section. And then we have the two pointers to them. Now here's the duplicate part. So you can see this is the get latitude, longitude, temperature, and the post latitude, longitude, temperature. Both of them have a latitude and a longitude input parameter. And then finally a response in that one. Those ones, watch the input parameters because they just get referred to once. And so up in our, where we define the references, they're just simple pointers down to here. So we actually, if the more duplication your API has, which is fairly common when you're talking about a single domain, you might be doing very common operations on the same kinds of things, or nested, 6 of these things are nested in here, or an array of these objects. You can just refer to that, you can just define the object once down in the definition section or the parameters section, and then just point to them using the JSON pointer. Anytime you update it, it's like a macro in other languages where you're just pound defining basically what this goes in. So when do we use JSON schema? My rule of thumb is working with JSON documents from a foreign source, sources that I'm not sure where they came from or could have been touched. It gives you a lot of bang for your buck. And OpenAPI, again, rules of thumb. I recommend using an OpenAPI spec if you're publishing an API to a wider audience. You can create beautiful documentation from it that I'll show you in just a moment. And it helps you keep your promises to your user that your API will be stable and backward compatible. Small private APIs with multiple implementations, maybe for different languages. There was a time at a company we're working for now where we're talking about standing up a standard specification of a particular API, but we weren't concerned about what language it was written in. But as long as we had this spec file, it could be written in Node.js or Perl or Python or Java, and it would behave the same way because we've described the inputs and the outputs. And that makes clients comfortable that they don't really care what the implementation is as long as you adhere to the specification. It gives you a lot of leverage. That said, I've been using JSON Schema related validators more recently than I used to. It used to be difficult to find good validators that would stay current. Like I said, JSON : schema is now out of date, and the author hasn't really kept up, but it's hard to write them. Batman, Jan Henning Thorsen seems pretty committed to keeping his up to date, so I recommend the JSON : validator. But this is, of course, one of the old dilemmas of open source generally, voluntary work. And, let's look for a moment at oops. There we go. I went to. Okay, so this is the editor. I've showed you this already. We can. The nice thing about the editor, so I can change this here, weather by Scott. It's going to be snowy, and it updates in real time on the right. You can see what your documentation might look like. This is just one form of documentation. There's no canonical documentation generator, but there are lots of them, and some of them make beautiful documentation out of your JSON specification. This one is pretty cool. You can you have a default section. This is where each of these can be snapped up and down. Again, this is where my description goes. Current temperature, that comes from right here. Description, current temperature. Parameters, I can try it out. There's get, what's expected to come back. Down here at the very bottom are models. Now what these are the, it's the definition section of our thing. So anytime you pull a thing out and put it in definitions, now you have something, kind of turns it into a nice solid noun that you can talk about and reason about and document separately. I wanted to show you this. This is really snappy. I'm going to take this out of full screen mode, though, so that I can go to here and, let's go into 06. This is where the difference between 05 and 06 in my presentation here is that 06 has everything in the definition sections. I didn't actually pull it up, but don't need to here. So now I say weather, daemon. So there we go. And now if we go into here, I will make this a little bit bigger. I'm going to reload this. Now this is just a file sitting on my file system. I'll show you, at the end I'll give you the git clone URL. This is just a GitHub repo. You can clone it and just change one parameter and see, I can go up to, I can set this right here to be any public URL. It's set to right now localhost 3000, which is where I'm listening. So this is pretty nifty here. Let's do this get. I can try it out. Oh, and you can see up here, again, weather by Scott, the version is put up in a nice little pill there. The base URL is set to localhost. I could set that to be, if I were to publish my API, I would set that to its public host name, and I wouldn't have to change anything else. And that could be a variable that's built at make time or something. So let's try it out. We've now, it shows me all my enumerated values that are possible from the spec. We'll go to central time. We're going to execute. It shows me the equivalent curl command. It gives me a request URL that I hit. It gives me my response. It gives me the content type. And then down here are the two possible responses, 200 and 400. We got a 200. I can try that with the temperature one. This one doesn't have, we'll do try it out. Now this is nice, watch this. If I set the latitude to something bigger than 90, oh, okay, and then we'll set the longitude to something valid. If I say execute, watch the latitude field. Gives you a little no. So we can fix that. We'll set it to 50. Now it's doing browser-side validation because it knows already all of the parameters and what they're, it can do that. Now my API is going to do that too, but that's another powerful thing about OpenAPI is that you can generate clients from it. That you can then give off, say, here's how you talk to our API. Here's one for Python, here's one for JavaScript, here's one for Perl. And people who use that will now get all of the validation on their side as well. So you can avoid round trips across the wire. Here's our curl equivalent. Here's the data back as a JSON body, content types, so forth. So that is the JSON UI, and it's a GitHub project. It's part of the Swagger project. They keep that current and up to date. It's pretty excellent. So here, this is the canonical place for JSON schema, JSON-schema.org. The current draft is some IETF thing, and it moves. It reads like an RFC, just a big long monospaced font. Swagger editor is here. Swagger UI. You can clone that. I have. I'll put some of this information in my own repo. This API Handyman I just found yesterday, and it looks really good. I didn't go through the whole thing, but it's like 10 parts that goes very gently through the how to do OpenAPI, and it also describes JSON schema and how they relate. And then the source code today's presentation is on GitHub right now. If you want to go clone that, I will go back and make sure I add these resources into the README. Any questions at this point? Big empty. Yeah, it's nice. Well, because it wasn't very good before. It's only gotten really good in the last 2 years, 3 years maybe. Yeah, so great. All right. Thanks, everybody.